Math 3, classwork 1.5. We are looking at finding the inverse of a function. This isn't any different than what we did before, just now we're using the function notation. You are given an f of x. F of x is the same thing as y. You are first going to take this equation, substitute the y with an x, substitute the x with a y, just flip them like how inverses go. And now I'm going over to the answers to show you there. You can see here the swap x and y, and then we are going to isolate the y variable. First, squaring both sides, and that undoes the square root, it'll be gone. Then add 5 to both sides, and that now is our inverse of f of x function. And make sure you understand this little -1 here, while it is technically a -1, it does not represent the -1 that you are used to. It is simply a symbol for inverse. It's a poorly chosen symbol, but it's what we've got. Also, this is not fully correct. We are about to address this issue, but know that this is not completely correct. In part B, we get to see that they really aren't quite inverses, because we draw the f of x function we began with, which was a square root graph. And in case you are having any difficulties, let me go back. The graphing y equals the square root of x minus 5 is the square root graph moved right 5 units. Then the f inverse is x squared plus 5. So that is the x squared graph moved up 5 units. They are not full inverses because it looks like f of x is only half the graph that f inverse is. You are expected to explain why these don't verify that they are inverses. And you can see the explanation I have there, which is what I just said out loud. How would you restrict the domain of the inverse function so that it is the true inverse of f of x? Look at the graph and notice which of these two sides of f inverse, which one is a reflection of this graph over the line y equals x. So if I draw y equals x, this one is the reflection. And then I want to look at what are the x coordinates. The x coordinates are starting at 0 and on toward infinity for the domain of just that section. And do realize you would be incorrect to put the left half of that parabola. What is the correct answer to f inverse of x? What is f inverse of x? And that is, it is x squared plus 5 over the domain 0 to infinity inclusive of 0. So now you realize that you have to be careful anytime you involve the x squared and the square root together as an inverse pair, because there are always issues of needing to restrict the domain of one of them in order to be a genuine inverse. So now the next part is I want you to find function composition g of h of x and h of g of x, where these are the g function and the h function. Function composition is where you directly plug one function inside of another. This one is showing the h of x function, which is x over 2 cubed minus 1, being substituted into the x of the g function. And after we substitute that in, we start simplifying. We have -1 plus 1, so those cancel each other out. And then we have cube root and 2 to the third power that are side-by-side operations. Those cancel each other out. And then 2 times x divided by 2, those cancel each other out, and we end up with x. When we go the other direction and find h of g of x, then the g of x function is going to be substituted into the x of the h function. So the h function is x over 2 cubed minus 1. And again, we just simply substitute all of that g of x right there where the x was for h. Then we take a look at what starts canceling. We have a times 2 divided by 2 right here, directly ready to cancel each other out. After we clean that up, we have a cube root cubed, which cancels each other out. And then we are left with a plus 1 minus 1, which also cancels each other out. So what you need to know is, in order to show that two functions written in algebraic form are inverses of each other, you need to show that whether you substitute one into the other or you reverse who gets plugged into the other function, you will go back to where you started. And that's the key of inverse functions. And the best way to explain that is through the Sneetches, one of my favorite Dr. Seuss books. So the Sneetches that have stars on theirs go into the machine to get the stars off. And they come out with the stars off and then go, wait a minute, the most popular thing is to get the stars back on. So they go into the stars on machine and come out with their stars and then go, wait a minute, but it's more popular to not have stars. Oh, I'm going to go into the take my stars off machine. Basically, these two machines together, whether you start by having the star, removing it, and then going through the machine that puts it back on, you wind up where you started, with a star. If you start without a star, then you go into this machine first to get your star put on. Then you go into the star off machine and you come out back the way you were with no star. And that is exactly what inverse functions do.